Okay, we're going to start our journey by learning about variables and constants. Let's start by two definitions. A variable is a name that we give to a storage location in memory, where we can store a value. And a constant is an immutable value. That is a value that we know at compile time, and that value cannot change throughout the life of the application. Why do we use constants? The reason for that is to create safety in our application. Imagine you're creating an application that involves some mathematical computation around circles. We have this number called p, which is 3.14, and we use that to calculate the area of a circle. That number should always be the same. We don't want to accidentally change that in our program. If we accidentally change that, everything is going to blow up in terms of the results the program produces. So we declare that number as a constant. And this way we create safety in our application. In C#, to declare a variable, we start with a type, followed by an identifier, and finally semicolon. Here, int represents integer, which is a number between -2 billion and +2 billion. Later in this video, I will show you all the primitive types that you need to know. Also, note that C# is a case-sensitive language, which means in this case, these two identifiers are different. One has lowercase n and one has uppercase n. When declaring a variable, we can optionally assign it a value, like what you see here. You don't have to, but there is one thing you need to know about variables, and that is you cannot use a variable unless you initialize it. So let's say if I declare this int number here and I decide to display it on the console, my application will not be compiled. I have to assign it a value before I can use it, before I can read it. I will show you that later when we jump to coding. To declare a constant, we start with the keyword const. Next we have the data type and an identifier, and here we have to initialize it with some value. We cannot define a constant without setting its value. There are a few things you need to know about identifiers. First one is that an identifier cannot start with a number. So you cannot have an identifier like the one you see here. Instead, you need to replace 1 with the word 1. Also, an identifier cannot include whitespace. So you cannot have an identifier like first space name. It has to be one word. An identifier cannot be a reserved keyword, like int that you saw earlier. If you're desperate to use a word that coincidentally clashes with one of the C# keywords, you can prefix that with the @ sign. And finally, as a recommendation, always use meaningful names. For example, avoid a name like FN. Instead, use first name. This way, your code will be more readable, more maintainable, and cleaner, and everybody will understand that. In terms of naming convention, here are 3 popular naming conventions that have been around in the C language family. We've got camel case, Pascal case, and Hungarian notation. With camel case, as you see I have bolded here, the first letter of the first word is lowercase. And the first letter of every word after has to be uppercase. With Pascal case, the first letter of every word has to be uppercase. With Hungarian notation, we prefix the name of a variable with the data type it uses. So here str represents a string. Hungarian notation is not used in C#, and I have noticed programmers coming from C or C++ background use that in their code. If you're one of them, I highly recommend you not to use Hungarian notation because C# developers are not used to that and they don't like to see Hungarian notation in the code. It makes your code look a little bit ugly. So in C#, to name your local variables, use camel case. So as you see here, the first letter of the first word is lowercase, and if we had more words here in the identifier, the first letter of every word had to be uppercase. For constants, use Pascal case. So here you see I've got a constant here, constant integer, and the first letter of every word is uppercase. Here is the list of most commonly used primitive types in C#. In fact, the actual list is slightly bigger than this, but I deliberately decided not to include those data types because they're hardly ever used. In fact, they are there for interoperability with other languages. I personally, over the past 12 years of me coding in C#, I've hardly ever used them. In fact, never. So I decided not to confuse you with too much details that you don't need. In the next slide, I've got a link here in case you want to learn about the other primitive types. So let's take a look at the table here. On the left side, I have divided these data types into 4 categories: integral numbers, real numbers, character, and Boolean. This column shows the C# data types, and these are C# keywords. Note that C# keywords are always lowercase. Each of these C# keywords or C# types maps to a type in .NET Framework, which is displayed in this column. So these types are part of the .NET Framework. And when you compile your application, the compiler internally would translate the C# keyword you use here to equivalent .NET type. The third column here shows the number of bytes each data type uses, and I have listed these data types from the smallest to the largest in each category. So in the category of integral numbers, you see byte is the smallest, it takes only 1 byte, whereas long is the largest and it takes 8 bytes. The more bytes we have, the more storage we have, and we can store larger numbers. You don't really have to memorize the range of each data type, but remember, byte can store a value between 0 to 255. Short can store a value between minus 32,000 to plus 32,000. Integer can store a value between minus 2 billion to plus 2 billion, and long is even bigger than that. In terms of real numbers, we have 3 data types: float, double, and decimal. Float maps to the single type in .NET Framework, and it takes 4 bytes. And as you see, it can store a very large number. Double is twice as big, so it uses 8 bytes. And decimal uses 16 bytes. The more precision you need, the bigger data type you use. We also have character, which is represented by char keyword, and it's 2 bytes. So characters in C# are Unicode. And finally, we have bool, which represents Boolean, which can be either true or false. In case you want to learn more about the other data types that I told you they're not really used, you can simply go to Google and search for C# built-in types, and the first page is the MSDN page that lists all the primitive types in C#. Now, most of these data types are pretty straightforward, but there is something tricky about real numbers. In this table, I have listed the data types we have for real numbers: float, double, and decimal. I've highlighted double because that's the default data type used by its C# compiler when you're using real numbers. So if you want to declare a float, you need to explicitly tell the compiler to treat the number you have as a float. Here is an example. I've declared a float, call it number, assign it 1.2. Here I have added the suffix f, and that is to tell the compiler to treat this number as a float. If I didn't have this f here, compiler would think 1.2 is a double, because double is the default data type for real numbers. And of course, I cannot assign a double number into a float, so the program would not compile. Same applies to decimals. So if you want to declare a decimal, you need to add the suffix m at the end of the number. In C# we also have a few other types which are not considered primitive types, and they are string, array, enum, and class. You'll learn more about them throughout this course. Okay, that's it for this lecture. In the next lecture, we're going to talk about the concept of overflowing. I hope you enjoyed this lecture, and thank you for watching.